Hello. Hello students. Today we are going to study important problems in SHM, and also we will look at the theory of SHM also. Okay. Simple harmonic motion. The general equations used in simple harmonic motion. This is a motion in which restoring force is directly proportional to displacement from mean position and always directed towards mean position. Okay. And in case this is linear SHM. In case of angular SHM, restoring torque is directly proportional to angular displacement and always directed towards mean position. Okay, this is angular SHM. This is linear SHM and this is angular SHM. The general equation for a particle performing SHM can be written as x equal to a sine omega t plus theta, where theta is initial phase. And the relationship are like this: velocity can be written as omega root a square minus x square, and acceleration can be written as minus omega square x. The time period of a simple pendulum can be written as 2 pi under root L upon G. The time period of spring pendulum can be written as T equal to 2 pi under root M upon K. This is time period of simple pendulum. This is time period of spring pendulum. And this is time period of compound pendulum. T equal to 2 pi under root K square upon LC plus LC upon G. This can be written as 2 pi under root L equivalent upon G. This L equivalent is the equivalent length of compound pendulum. These are some important definitions and formula which will be used in solving the problem of SHM. Let's start solving the problems. In this question, it is given the equation of particle executing SHM is x equal to 5 sine pi t plus pi by 6. The amplitude, phase constant, time period and maximum speed will be. So dear student, we can compare this equation as x equal to a sine omega t plus theta, or x equal to a sine omega t plus phi, whatever you want to write. X equal to a sine pi t plus pi by 6. If we compare, we are finding amplitude of the motion is 5 meter, and omega, A sin omega t, omega is pi. So dear student, time period is what? Time period is 2 pi upon omega. So this is 2 pi upon pi. So this is 2 second. This is second inverse. And what is the initial phase? Initial phase is pi by 6. So amplitude is this, time period is this, and initial phase is this. Okay. In the question, it is asked what is amplitude, what is phase constant, what is time period, and what is maximum speed. And dear student, for a particle performing SHM, maximum speed is given by A omega. For a particle performing SHM, maximum speed can be written as A omega. What is amplitude? 5 meter. What is omega? Pi. So answer is 5 pi meter per second. Okay. So this is the answer. Now let's see another question. A particle having mass 10 gram oscillates according to the equation x equal to 2 centimeter sine 100 per second t plus pi by 6. This is pi by 6. Find the amplitude, the time period, and the force constant, the position, the velocity, and the acceleration at t equal to 0. Let's start. Compare this equation with general equation x equal to a sine omega t plus theta or x equal to a sine omega t plus phi. By comparing, we can find amplitude equal to 2 centimeter, omega equal to 100, and theta initial phase is pi by 6. Okay. So dear student, in the question it is asked what is amplitude. So amplitude is 2 centimeter. Time period, from comparison we get omega equal to 100. So time period can be written as 2 pi upon omega. This is 2 pi upon 100. So this is pi upon 50 second. This is the time period. Now force constant K. K is what? M omega square. What is M? Mass is given 10 gram. 10 gram converted to kilogram, 10 into 10 power minus 3. And what is omega square? This is 100. 10 power 2 square means 10 power 4. So dear student, this will be 100 Newton upon meter. So we got amplitude, time period, and the force constant. Now position, velocity, and the acceleration at t equal to 0. Substitute t equal to 0 in the equation. If you substitute t equal to 0 in the equation, you get x equal to 2 sine pi by 6 at t equal to 0. Position is 2 sine pi by 6. This is centimeter. Pi by 6 means sine 30 degree. Sine 30 means 1 upon 2. This is 1 centimeter. So this is the position at t equal to 0. And now velocity. Differentiate the equation of the position. V equal to dx upon dt. We get V equal to dx upon dt. After differentiating the equation of position, we are getting 200 cos 100t plus pi by 6. At t equal to 0, this will become cos pi by 6. This is 200. Cos pi by 6 means cos 30 degree. Cos 30 degree means root 3 upon 2. This is 100 root 3. Unit will be centimeter per second. And dear student, what is acceleration? Again differentiate the equation. You will get acceleration. A is dv upon dt. We get 200 minus 100 sine 100t plus pi by 6. At t equal to 0, this will be sine pi by 6. This is 200 into 100 into sine pi by 6 means sine 30 degree. This is minus 2 into 10 power 4 into 1 by 2 and minus. So this is answer is minus 10 power 4 centimeter per second square. Okay. This is the acceleration, okay? So all these things we have calculated. The equation of motion of particle started at t equal to 0 is given by x equal to 5 sine 20t plus pi by 3, where x is in centimeter and t in second. When does the particle first come to rest? Rest means velocity becomes 0, okay? First have 0 acceleration, you know, in case of SHM, accelerations become 0 at the mean position, okay? At mean position, force becomes 0. First have maximum speed, speed remains maximum at the mean position, okay? So we can easily answer. All the questions we can easily answer. This is the equation. First come to rest. If we just locate the equation from the phasor diagram, we will find initial phase of the particle is pi by 3. Now, particle will come to rest at the extreme position. To reach the particle at extreme position, you know this is 60 degree. So this particle has to travel 30 degree. Then the particle will reach here. And if we compare x equal to a sin omega t plus theta, omega is how much here? Omega is 20. Omega is 20. Okay, so time period is what? Time period is 2 pi upon 20. That is pi by 10 second. Okay. So particle will have to travel 30 degree angle. To travel 30 degree, in traveling 360 degree, time is t. In traveling 30 degree, time is how much? T by 12. So dear student, particle will come to rest in a time t equal to t by 12, means t pi by 120 second. This is the answer in the first question, A part. Now in the B part, first have 0 acceleration. 0 acceleration will come when the particle will reach at the mean position. Dear student, this particle will reach at the mean position like this. This will come here. So when the particle will travel 120 degree angle from here to here, 120 degree again, 90 plus 30, then particle acceleration will become 0. In traveling 120 degree angle, time will be how much? Suppose this is t dash. This is how much? T by 3. So answer will be pi by 30 second. Okay. Now first have maximum speed. This is the time. When acceleration remains 0, speed remains maximum. So this is the time when particle speed will become maximum. Okay. So in the option C, the same time will be there, pi upon 30 second. This is the answer. Okay. So we have solved all 3 sections A, B, C. A simple harmonic motion has an amplitude A and time period T. Find the time required by it to travel directly from option A, x equal to 0 to x equal to a by 2, option B, x equal to 0 to x equal to a upon root 2, option C, x equal to a to x equal to a by 2, option D, x equal to minus a upon root 2 to x equal to a upon root 2, option E, x equal to a upon root 2 to x upon a. With the help of phasor diagram, this problem can be solved in seconds. Okay, and this is very good question and important question. If we take NEET and JEE exam in point of view, okay. So dear student, what is being asked? The particle is performing simple harmonic motion. Amplitude of the motion is A. Time period is T. Okay. Now, with the help of phasor analysis, we will solve all the sections very frequently. See here. X equal to 0 to x equal to a by 2. The particle will come from x equal to 0 to x equal to a by 2. See here, x equal to a by 2 will come into picture when this angle will become 60 degree. Then only this projection will become equal to a by 2. When this angle will become equal to 30 degree. Okay. So when the particle will travel 30 degree angle, when the particle performing uniform circular motion, you know what is SHM? A simple harmonic motion is the motion or projection of particle performing uniform circular motion on the circle's diameter. Okay. Simple harmonic motion is the motion or projection on surface diameter of particle performing uniform circular motion. In case of uniform circular motion, omega remains constant. Okay, this is fundamental fact. So dear student, in traveling 30-degree angle, time taken by the particle will be how much? In uniform circular motion, omega remains constant. In one time period, that is 360-degree angle, time taken is equal to time period. So time taken by particle in moving 30-degree angle will be equal to how much? T by 12, 1 upon 12 of the time period. Okay. So dear student, time period is given T. So answer for the first question is T by 12. Now from x equal to 0 to x equal to a upon root 2. Now you can see here, if it has to come at x equal to a upon root 2, this angle should be 45 degree. If it is 45 degree, in traveling 45 degree, in traveling 90 degree, the time is T by 4. In traveling 45 degree, time will be T by 8. Okay. In traveling 45 degree, time will be T by 8. Look at this diagram. This is 45 degree. Then it will become a upon root 2. Okay. Now from x equal to a to x equal to a by 2. Okay. X equal to a to x equal to a by 2 means particle is coming from extreme position. Okay. Dear student, look at this diagram. This is x equal to a and this is x equal to a by 2. This position will come when angle rotated will be equal to 60 degree. 60 degree means how much? 60 degree will be equal to how much time? This will be T by 6. Okay. So time here will be equal to T by 6. Around mean position, particle travels faster because at mean position velocity of the particle remains high. Okay. At mean position velocity is maximum, at extreme position velocity is minimum. Okay, in SHM. Now see, x equal to a upon root 2 to x equal to a upon root 2. X equal to minus a upon root 2 to x equal to a upon root 2. Okay. So dear student, this is also very simple question. See here. This is 45 degree, this is 45 degree, this is 45, this is 45. So in moving from minus a upon root 2 to a upon root 2, the particle is to travel by an angle 90 degree. Okay, in traveling 90 degree, already we have solved 90 degree means T by 4. So dear student, in this case time will be equal to how much? T by 4. Now in moving from x equal to a upon root 2 to a, x equal to a upon root 2 to a. Okay. Now you can see here, this was the position of x equal to a upon root 2 in moving to a. Okay. So again, the particle has to travel 45 degree. 45 degree means what? This is again T by 8. So time taken by particle is T by 8. Time taken by particle is T by 8. Okay. Hope you understood. A particle is executing SHM with amplitude A and has maximum velocity V0. Find its speed when it is at distance a by 2 from mean position. Now we can use relation of velocity with position. Okay. What is that relation? V equal to omega root a square minus x square. With the help of this relation, we can find maximum speed remains at mean position, that is given V0. V0 is what? Dear student, maximum speed is a omega. Now in the question it is given, we have to determine the speed at x equal to a by 2 from mean position. Okay. So substitute the value v equal to omega root a square minus a by 2 square. After solving this equation, we will get a square minus a square upon 4. So omega root 3 by 4 a square. This will be what? This will be omega a root 3 upon 2. And what is omega a? This is V0. Okay. So dear student, what is relation? V equal to V0 root 3 upon 2. This is our general relation. This is our general answer. Okay, at x equal to a by 2, speed is root 3 upon 2 times of the maximum speed. Okay, the position, velocity and acceleration of a particle executing simple harmonic motion are found to be having magnitude 2 centimeter, 1 meter per second and 10 meter per second square at a certain instant. Find the amplitude and time period of the motion. Okay, position, velocity and acceleration of a particle executing simple harmonic motion are found to have magnitude 2 centimeter, 1 meter per second and 10 meter per second square at certain instant. Find the amplitude. Dear student, velocity is given 1 meter per second and acceleration is given 10 meter per second square. Here there is some unit problem. Okay, this should be 1 centimeter per second and this should be 10 centimeter per second square. We are just correcting this. This is this. If we correct these values, then see here what is at x equal to 2 centimeter. V equal to what? 1 equal to omega root a square minus x square. Okay, and what is acceleration is given 10 equal to omega square into x. So from here we can find omega. So omega square equal to how much? 5. Omega is how much? Under root 5. Once omega is received, you can easily find a 1 equal to how much? Under root 5 a square minus 4. So dear student, make the square 1 equal to 5 a square minus 4. So 1 upon 5 equal to a square minus 4. So what is a square? A square equal to 1, 4 plus 1 upon 5 means 21 upon 5. So what is a? A equal to under root 21 upon 5. Centimeter. This is amplitude. Okay. So this is how we can solve the question. Okay. The maximum speed and acceleration of a particle executing simple harmonic motion are 10 centimeter per second and 50 centimeter per second square. Find the positions of the particle when speed is 8 centimeter per second. Dear student, in the question it is being asked, maximum speed is how much? 10 centimeter per second and acceleration is how much? 50 centimeter per second square. Find the position of the particle when speed is 8 centimeter per second. Okay. So dear student, maximum speed formula is how much? A omega. This is how much? 10. And maximum acceleration is how much? Omega square. This is how much? 50. If we divide these two equations, this is equation 1, equation 2. If we divide these two equations, equation 2 divide with equation 1, we get omega equal to 5, 50 upon 10. Okay. Now, the position of the particle when speed is 8 centimeter per second. Okay, very simple. X equal to A. If omega is 5, A will be 2. A sine omega. Okay, question is speed is given 8 centimeter per second. So 8 V equal to omega root A square. A will be what? Omega is 5, A will be 2. V equal to omega root A square minus x square. Very simple. Now 8 upon 5 equal to 4 minus x square. Just make the square. No need to make the square. 8 upon 5 equal to 4 minus x square. No. Okay. What we are getting here? 8 upon 5 equal to under root 4 minus x square. Make the square on both the side. We will get 64 upon 25 equal to 4 minus x square. So x square equal to how much? 4 minus 64 upon 25. This is 100 minus 64 means what? 36 upon 25. So x is what? 6 upon 5 centimeter. This is the answer. Okay. Thank you.